everyone. I am April Sargent. I'm the compliance manager at RMI. I have been thoroughly involved in the pilot studies for the Shinchi dehumidification system. And I just wanted to welcome you to our presentation on how to stop hauling water and a little bit about our pilot studies in New Hampshire and Vermont. As many of you may know, RMI has been a leader in residuals recycling for the past 25 years. We help municipal and industrial wastewater treatment plants recycle residuals such as short paper fiber, hydrosolids, biosolids. RMI has handled dried Class A in the past and has become very familiar with the benefits of having a dried product. So RMI had a few strategic partnerships in mind. We partnered with Brattleboro, Vermont, who was our first pilot installation. And our next was Hooksett, New Hampshire, both of which were very successful. Brattleboro has since wrapped up their pilot study, and Hooksett is about 6 months in. We will talk a little bit about both installations and kind of what we're doing now, our next steps, in this upcoming presentation. Joining me will be Charlie Hansen, our senior project manager, and Steve Nurmi, our sales manager. And we'll kick the presentation off with a little video about our Hooksett installation.
The top 3 reasons somebody should go with the Shinchi technology, one would be cost savings. The footprint is the smallest on the market. And the third being, it's simple. It produces an on-site Class A product that's ready to ship directly to farm. Competitive products are hundreds of RPMs, hundreds of degrees. We're 5 RPMs and 170 degrees, much more of a dehumidification than a drying. The Shinchi 4800 evaporates 4,800 kilograms of water in a 24-hour period. This facility is taking in 16.5% solids and discharging 93% solids. 2 proprietary things with Shinchi is the slitter and the heat pumps. The heat pump's extremely efficient. The slitter is rollers, kind of a pasta machine, versus an extrusion, which can clog up with the fiber. So we're going to take you right through the slitter, where we increase the surface area by making noodles. Those noodles will be laid down on a belt. It's a perforated belt that allows dry, hot air to come up through the bottom, as well as convection on the top. It travels down a top belt, it turns once. It comes back on the bottom belt, and it's discharged at 90% solids. The footprint is the smallest on the market. There are really only 2 sizes. You've got a small unit and you've got a large unit. So it's not like we have models for all these applications. It's modular. One is 7.5 feet wide, the smaller unit. 10'2" is the larger unit.
Here at Hooksett, it's a very challenging type of wastewater solids to get the water out of. This is just what they call a secondary plant. There's no primary sludge being wasted off the process. After some initial challenges here, we're consistently getting about 17%, and the dryer is handling it great. We're easily able to keep up with the solids production coming off the process. So in this case, at this Hooksett installation, it takes about a little over 3 hours to get all the way through those belts. And at the end, you get out a 90+% dried product. We got into this because we were interested in making a great dried product and reducing the impact from having to transport all this material. When something's wet, you might have 5 loads of it, but when you dry it, you have 1, and that works out great.
We found operation costs and maintenance costs to be very low. It's about once a week maintenance, takes 1 to 2 guys about half an hour, 45 minutes. The monthly maintenance takes about 4 guys, 30 minutes to 45 minutes. And as far as addressing the costs, the superintendent here installed a meter just on the room itself, which encompasses the dryer and all the conveyance. So we can get real-time operating costs. To run the dryer 24 hours a day, it costs about $5.85 an hour. That also translates to be about 180 kilowatt hours to dry 1 wet ton of product, which is even better than we could have expected. RMI is committed to compliance, and our commitment to compliance ensures that the permitting process, not only for the installation itself, but for wherever you choose the end product to go, and we really hope that that's land application, is a smooth, easy transition. And most importantly, RMI is providing a solution to our municipal and industrial clients.
Hi, I'm Charlie Hansen from Resource Management, and we were fortunate to partner with such a good treatment plant in Hooksett, New Hampshire. When we started pursuing the Shinchi technology, the drying technology, they approached us about learning more about it. Fast forward, we got the dryer and we got it installed and up and running last May, the end of last May. Recently I had a chance to sit down virtually with Ken Canati, the superintendent at the Hooksett Wastewater Treatment Plant. So Ken, maybe you could start off by telling us a little bit about the Hooksett Wastewater Treatment Facility.
We do about 700,000 gallons a day, small plant. We do not have primaries here. We're a completely secondary plant. We've also added a solar component recently. It's going to lower our electric bills by 80% is what they're telling us right now.
Ken, maybe you could tell us a little bit about what your thoughts were when you first got thrown into, wow, there's a big box in my truck loading bay.
I asked lots of questions of Charlie and Akram and the entire team. And we were running 3 truckloads a week to Merrimack. Now we fill 1 container for RMI, and it takes us 2 to 2.5 weeks to fill the container. So we've eliminated 7 runs with a truck to 1. That's a lot of water we're not hauling anymore.
And what do you think is the most important thing from a sludge management perspective?
It's a dry product now. It's an odorless product now when we leave out of here. Once it gets 85%, there's no odor to this material at all. So we get to that 90%. Now it's a Class A. We can farm apply it anywhere we need to. So it makes it lots of options for us to go with instead of just hauling to a landfill.
Are you going to consider this technology as part of the permanent solution?
Yes, we're definitely looking at this as the solution for what we need right now. The machine works. It's going to work into the future, and it's going to save dollars into the future. And I think all of us need to look at what the hauling costs are now and how much it's going to cost us more, especially with PFAS involved in this as well.
So thank you very much, Ken, and thank you to the team at Hooksett.
Thank you, Charlie, for bringing us in.
So RMI has worked with our valued partners in this initiative, and we had a dryer installed at Brattleboro, Vermont, a client we've had for over 25 years, managing their biosolids in a land application program. Well, we concluded the Brattleboro pilot, went very well. We determined that we certainly would like to put a larger machine in there, and they actually would like to build a separate building to put all their drying into. So once we concluded that, we were approached by a town just north of Brattleboro, the town of Rockingham. The main municipal part is called the village of Bellows Falls. And Bellows Falls has a nice little plant, an RBC plant with anaerobic digestion. They've gone through a number of upgrades over the last 10 years. Chief operator there, Rob Wheeler, was very excited to add drying to a recently upgraded dewatering unit. So recently I had a good fortune of being actually in person down at Bellows Falls, where we got to catch up with Josh, the lab manager there, to talk a little bit about what the drying unit installed at Bellows Falls has meant for them.
We successfully completed a pilot program with our longtime partner, Brattleboro, Vermont, at the end of last year. We also had friends up here in Bellows Falls who had been following and seen the dryer operating in Brattleboro, and were very interested to see if we could bring that unit up here. So what we did is we put together a package, did the evaluation of the flow and the type of products they were making here, and put it all together. And within about 6 weeks, we actually had the dryer physically on site and installed and ready to go. And we've been making dried biosolids here for approximately 4.5 weeks.
My name is Josh Kemp. I've been here for 13 years. I have a grade 1 license and I have a grade 1 in laboratory. From beginning to start, we have RBC facility. We produce around 350 wet tons a year, anaerobically digested. And the service area we provide is town of Rockingham, Walpole, and North Walpole. Historically, we were going to Claremont, New Hampshire and disposing of our sludge, and it was getting composted and reused. 2 years ago, they had a process stop in New Hampshire, and it caused us to go to Coventry, Vermont. And now our cost of our sludge disposal has tripled. With the Cincinchi dryer that we are now using, this will cut our costs quite a bit. I feel that the cost of bringing the sludge to landfills is going to be not only uncost effective, it's going to be odorous, and there's going to be other issues that are going to cause places to close down fast. The Cincinchi technology was pretty much a no-brainer, but the cost effectiveness of drying it, we're now filling one dumpster compared to 4 dumpsters in a week. The beneficial reuse of being able to use this drying product on farms is going to be 100% better than putting it in a landfill and wasting the opportunity to use the nitrogen. I think that the Cincinchi dryer is the way to go, and a lot of plants need to really consider having that process put in and have it looked at.
Hi, I'm Steve Nurmi. I'm the sales manager with Resource Management. I've been working on the Cincinchi technology for a little over 2 years now. And what I'd like to do is take you through an overview of the dehumidification process. That process starts with what we call the slitter box. The slitter box is an area where we receive the cake that's coming in. We take that cake, 18 to 25% solids, and we put it into a noodle form. It's almost like an industrial pasta machine. So by creating these noodles, we're increasing the surface area, and we lay that down on the upper belt. There are 2 belts, an upper belt and a lower belt. So the air is traveling through the belt and the product, while it's also a convection process. So as it turns from the top belt to the bottom, that product's just flipping once, minimal movement, very stable product. In that process, the moist air is evaporated by a set of condensers and discharged through a condensate pipe back to the headworks. That dry hot air, or the moist hot air, is going to proprietary heat pumps, which are extremely efficient. They're drying that hot air, bringing it back up to temperature, and recycling it right through that process with the belt. It's 5 RPMs, 170 degrees, very different than the other technologies that are out there. The entire process is controlled by one touchpad, a touch screen that is on the dryer. That touch screen on the main page shows you everything that's happening from the slitter through the belts, your temperatures, the compressors that are on and off. They'll shut off for efficiencies when you reach temperatures, and they're not running all the time, and all that is visible on one page. On another tab there, it gives you all the parameters to really dial in to the specific characteristics of your sludge. You control the upper belt speed, the lower belt speed, the amount of product that's being applied to the belt through the slitter, all on one screen that's there. This process does provide an on-site Class A, but to be Class A, you need to achieve vector attraction reduction and pasteurization. And in doing that, pasteurization is achieved by spending over 30 minutes on that lower belt. Vector attraction reduction is achieved with the 90% solids being discharged on the other end. If the facility is anaerobically digested and does meet the 38% reduction, it's only required to be 75% solids on the other end, but we almost always shoot for that 90%. It just makes a more manageable product and a better fertilizer. But in the event it does go towards landfill or other applications that are required by regulation, this is still a great means to manage the product. It's taking the water out, it's reducing the weight that's being hauled, it's reducing tipping fees that are being paid on a weight basis. Whichever direction the market goes, it's just producing a better product. As far as maintenance, maintenance is pretty minimal on this. It takes 2 people about a half an hour once a week to clean the filters. There's a set of combs under the rollers in the slitter box that, as they do accumulate fiber, that could be 2 to 4 weeks. Typically, we'll take those out and just clean them and put those back in, grease the bearings and the fittings that are up there on a monthly basis. But you're talking a couple people, 30 to 45 minutes once a week to maintain the dryer. Differences in the 2 facilities that we're working with right now. We've got Hooksett that's feeding a hopper with 18% cake. dewatering during manned hours, and feeding the dryer throughout the night. Bellows Falls is directly feeding the slitter out of a PW Tech screw press and only working during manned hours, and that's going in at roughly 26%. Same machine, slightly different applications, delivering the same 90% total solids on the end. Top 3 reasons to choose this Shinchi technology. First off would be cost savings. It's competitively priced in the marketplace, and it's extremely efficient to operate. Secondly would be the footprint. It's the smallest footprint on the market, the 4800s that we're talking about here today, and they're 7 feet 2 inches wide, 8 feet high, and 21 feet long. So a very small footprint. And then lastly, they're simple to operate. They're really a neat technology that is dehumidifying more than drying, and there is minimal operator involvement during the day. I appreciate your time, and I'll turn it back over to Charlie.
So thank you all for spending the time to learn a little bit more about the Shinchi technology, the belt drying technology that we are employing here at Bellows Falls in Hooksett, New Hampshire. Please stick around because we will be available to answer any questions. And once the COVID-19 situation stabilizes, as soon as it does in both New Hampshire and Vermont, we will be resuming actual physical tours of the drying technology.